Welcome to the video on the dynamic initialization of arrays in C. In this video we are going to learn about how arrays are dynamically initialized in C, and we are going to see a comparison between how array code are written in Java versus how they are written in C. So before beginning, there are a list of prerequisites that I have mentioned which must be fulfilled for your clear understanding of the concept that I'm going to deliver in this lecture. Well, leaving all points, the last point is very important. You must be familiar with pointers in C, because dynamic initialization of arrays are basically pointers which have been allocated some memory, and we are dealing with pointers here. So that is the reason why I require that you have your concepts cleared in pointers. And in this tutorial we are going to learn how to declare dynamic arrays in C, how to take inputs in those arrays, how to display those arrays, and finally how to pass those arrays to a function so that we can do stuff with the array in that function. So without further ado, let's start. Well, here I have a bit of Java code which does nothing much. It takes the number of students as an input from the user. It declares an array having its length, the number of students. It takes the marks of the students as an input. It then computes the average, displays all the marks of the students, and then displays the average marks. Well, so here it goes. So ignore this part for the moment. I'll be explaining about this, and you might be knowing what this is. All right. So here we are taking the students as an input from the user. We're declaring an array, and as you know, this new keyword, what this new keyword does is it allocates students amount of memory to this array marks. All right. After that, we are taking inputs in this marks array, and then we are computing the average here, and computing the average here, and we are printing the marks of the students and then the average. Pretty simple program. Well, let's see how this is done in C. Alright, so here ignore this for the moment. Here we have the students, the loop variable, and yeah, notice this point. This is important. Well, I guess I should have put a terminator here, and this would go down, go to. Alright. So whenever you're trying to declare an array which is to be initialized dynamically, or whose length would be a variable, you must declare your array like this, star and your array name, not the other way around, not arr this, because if you write this, it would throw a compilation error that it is missing the length. Well, let's see what the error is. Alright, so save, compile. There are three errors. So size of marks is unknown or 0. So this is not allowed. So therefore a star marks. This is basically a double pointer whose size is 2 bytes, and this double pointer would point to the first or the base address of our array. Now we are taking the input from the user as the number of students, then we are defining the array. This is how we define a dynamically initialized array in C. So here we are making use of this function called malloc, which is present in the stdlib.h header file, which stands for standard library. What malloc does is it allocates a contiguous location of student size of this much amount of memory. Like the size of operator, what it does is it sends the size of this data type. As we know, in a 16-bit compiler like Turbo C++, which I'm using right now, the size of double here is 8 bytes. Now 8 multiplied by students, if the number of students is 5, for example, then the total number of bytes that malloc would allocate for this marks array would be 40. and this would be a contiguous array, and the base address of this array would be stored in marks. Now you must be thinking, why are we doing this typecast? Because this function malloc returns a void pointer, so therefore uh, we need to typecast it to a double pointer, because our marks is a double pointer. Alright, so and this is how we take input in a dynamically initialized array. What we do is that we write the name of the array, and then we add I to it. Now you must be thinking what this does. Well, for this, let us head over to my teaching board. Alright, so this will be 1000. So consider an array of 5 elements whose base address is 1000 and which goes up till 1032. Alright, so marks would contain the address 1000. Now when the value of I is 0, 1000 plus 0 is 1000, and therefore any value would be stored here. For example, 56 for example. And then when the value of I is 1, marks plus I would be pointing to 1008, and using scanf function will take input in this memory location, for example 99, and similarly the rest would follow. So this is basically it. This is how we take input in our array, and we're initializing total with 0, we are adding up total, and it's quite the same as in Java, marks square bracket I. In some books you might come across this kind of a notation. Well, it's all the same. It's telling the compiler to add I to the base address of marks and then obtain the value using this star, which is known as a dereference operator. Alright, so average calculated total by students, and then we are printing as usual, as we did in Java program. Now let's head on to our Java program and let's see how we can make use of a function to display our array. I'll just comment this part out. So we are passing the array to our display function, which accepts a double array. We are finding out the length using arr.length, and we are printing the array elements. Simple, right? Alright, so yeah, we can similarly calculate the size of the array by doing this operation. I'll put this in a comment line. For example, in size, as we know the size of the array, therefore we are it is not required for us to calculate the size of the array all over again. So it can be calculated like this. For example, the name of our array is marks, so therefore we would do this kind of an operation: size of marks divided by size of the first element of marks. Alright, now a brief explanation of how this works. For example, let's see, Malloc here allocates 40 bytes of memory when the size of students is 5. Considering that example, size of marks would here be 40 bytes. Size of marks will here be equal to 40 bytes. Similarly, as each element of marks is of the type double, therefore size of marks 0 would be equal to 8 bytes. So 40 divided by 8 gives us 5, which is the length of the array, and this is how we calculate the length of the array if the length is not known. Alright, so let us not use this for loop anymore to print the marks. Let us use a function. Alright. Before defining a function, we must put this declaration before the main function, which is the signature for the function display. Here, the array is accepted as a double pointer, and unfortunately, its size has to be passed in this function too. We'll see why it is so. Well, if you try to calculate the size of the array inside our function, this is the result that we get. So let's see what's the size of the array here. All right, so the size will be replaced by length. Let's run this. All right, so let the number of students be 1 and the marks for student be 100. See, the marks are not being displayed. The average marks is displayed because it is well defined under main, where the array has been defined and it's accessible there. But the length was wrongly calculated. Let's see what the length is. Alright, length, alright. 1, 10 suppose. Oh, I'm really sorry. I should have uncommented this line. No method calls are being done here. Alright, so suppose 1, suppose 100. The length inside display is 0. How come? Oh god, it's wrong, right? How come it's 0? Well, the thing is that the size of a double pointer is of 2 bytes, or for that matter, the size of any pointer in the C, in a 16-bit C compiler, is 2 bytes. Let's see if that's true or not. So yeah, we're printing the length. We're basically printing ARR, the size of this double. So 1 is 2 bytes, and the size of ARR 0, which is a double element, has a length of 8. 2 divided by 8 is 1 by 4, and as we are storing it in an integer value, the decimal part is being truncated and we are getting the result as 0. So this would not work. We have to pass the size of the array, because the compiler or the method here does not know about ARR being an array. We don't. It only knows that this would accept a double pointer which is pointing to a location in memory. That's all. That's all that this method knows. All right. So size. We'll run this again. 2 students. One has got 100. One has got perhaps 99. The marks are 199 respectively. See, so easy. There's one more thing that I forgot to mention. After declaring an array this way, like dynamically initializing an array, we must use this line to free this amount of memory, because this is required. This is not required in Java, because Java has automatic garbage collection. Therefore, whenever our program terminates, all the referencing memory and all, they're all collected and they're all closed. But not in case of C. In case of C, we have to explicitly free this much amount of memory by using this method. Alright, so some important points that we need to note. Malloc and free are declared under the standard library header file, and we must include this in our programs for us to dynamically initialize arrays. Alright, so that's for this video. See you in the next one. Bye.